source, and the meter provides the voltage and bias the solar cell, and it measures the current through the solar cell. And this controls the lighting intensity of the light. And if we turn it to the 14.7 volts, and it provides the light intensity just one sum. We just a quick measure. And this is the IV curve for typical solar cell, and all the parameters are here. Everyone should try once. That's it. And we should, when we finish measuring, then click test the results. Let's see. And you can find the data in this file.
No, the IV data folder.
This is the data. And what you should do is use these data and plot the IV curve in your computer.
So where do we get the data? You want to put it on a pen drive, or can you put it up on Twitter or server?
Yeah, the best idea is you can mail everyone.
That works too.
Anyone want to try this?
What's the light? What's it using as a light source? I guess data. Like, is it the same spectrum as?
Yeah, it is almost the same spectrum as a one AM 1.5.
What do you guys use to check that out? Is it just spec out that way?
We actually have an NREL calibrated solar cell.
Yeah.
That looks something like that. So basically, we just take this, put it into that, and connect this to the source meter. And we have a data sheet which shows that for one sun, you should get this much current. So we tune that according to the data sheet on this cell, and that's how we know that 14.6 volts is one sun.
Gotcha.
So
we
want to try this?
Sure.
Should we go on to the
We can go on to the next one. It's kind of visual language.
No, because you don't have
What I want to come back higher. Not that I want to try this. I will go on to the content efficiency.
What, is this thing just a contact probe, or is it you actually okay?
You touch the.
life easier if you turn this down.
You can see the probe touch the electrode on the outside.
The back surface is contacted.
Yeah. Maybe if you want to do it, you can just take the cell out and put it yourself.
So the front is aluminum too? What is the
Let's
front?
go to the front is titanium and silver.
Titanium and solar?
I don't know what we're doing here, so we just
Poke it.
I can. Or do we want to set it up again, or we just run it in?
Take off the solar cell and touch it yourself.
Like a probe?
Yeah.
So it's
Okay.
anything else.
Very thin.
And so you just center it in there, right?
Yeah.
And then you align the probe to, I guess, the center of the.
Yeah. So now
Put it away and fasten this tape.
It's kind of an eye test to get it in the middle, isn't it?
Because what happens is that
Where do you know, as Julian, like, where exactly you
when
need
you
to
push it, when the probe actually
place the probe over there? Where do you exactly yeah. Oh, that's good.
just take it.
Oh, back it.
The whole probe station is like
Oh,
1 to 2 inch away.
Young guys, man.
I'm so big that I don't need the
Yeah, focus it down.
So the front surface is all like all the way to the curve together. Not like ours.
Can you take a picture of the videotape that broke through the magnifying glass?
Yeah. So I want to.
What's true?
No, look, I mean, if you
So,
put
I mean, I
this
just,
pin on the, like, not in the central line, the contact right now is
It's
on the big.
it's on the central line. Does it need to be in the middle of the central line? No.
got to be in the
Anywhere is fine.
center of
Right?
the bus.
All right, and then
Because if
do
you
we turn
connect
this up
anywhere,
to?
the CD will
Go
not
ahead.
be there.
Oh, so
Why is that?
But if you do the math work,
So all that's like there's a middle.
So is this designed for that?
all thick bus bar.
And then
And then you have fingers
Right,
running
and
across.
then
and then you're going to put it in the middle of the dual contact.
Yeah.
so the computer is controlling the voltage output and everything.
Yeah.
So this is just a source meter and that is just varying the voltage.
No.
The program just varies the voltage.
Yeah, okay.
What is this like a?
There's going to be a report.
What kind of programming is this? What,
It's a Lab2.
okay.
That was right about the experience.
All right, and then so
Did you guys write the
then I've got the. Okay,
Which one?
this is the one you made. This is the one I made. Vice versa.
Mine must have a different one. I must expect a different one
Okay.
because I have labs and reports.
How many labs do you have?
Okay.
Oh,
Not forward.
So you did nanophotonics maybe?
No.
Just a photonics?
Yeah. They change the name of the class every time.
So how much does it vary like time to time? Like how hard does it replicate the exact same curve?
It depends on where you touch because
They have to change the name.
if, for example, this is how your front electrode looks like.
Mm-hmm.
So if you contact it here and measure your IV, you will see that the series resistance is quite high.
Okay.
And the ideal place is to measure it at the center.
Okay.
That's where the series resistance is the lowest. So depending on where you are, where you deviate from that center point, your curve will go on changing.
At this moment, I mean, it should be exactly the center.
It's not. So someone else will say.
Sort of center.
So how would you
I give it a
determine like
shot.
shunt resistance here? Like, well, it calculates it for you.
Yeah.
Like
But yeah, I'll show you.
physically on the cell itself.
Yeah. So if you look at the IV curve, it looks like this. This is in the fourth quadrant.
Yeah.
So if you take some points here near VOC and you draw a slope,
Yeah.
that's where you get the series resistance.
Yeah.
And if you take 3-4 points here across the ISC,
On draw slope.
yeah,
Okay.
here are some points, and that gives you the shunt resistance.
But physically on the cell itself, like the shunt resistance
Shunt resistance, okay, if you look
is
at
from like top to bottom?
yeah, top to
Okay.
bottom, yeah.
I think that's any kind of reason.
So you somehow like it has to be isolated I guess, from each other.
Definitely not recode.
So one, maybe this you get this one. Suppose you have a cell like this, and
Yeah.
That's the
you have
connection
an
from
electrode
the
like
base.
this.
Yeah.
And
Huh?
if there's going to be some aluminum here,
Yeah.
and if this is the thickness of the sample,
Yeah.
during your annealing, some aluminum can actually
Has
do
anyone been
that.
able to figure out how
So
to
it
get
creates a
the
shock,
saturation currents out of it?
So
It creates an additional part for
No.
oh, so
Oh,
you
you're talking
like
about the program,
okay,
the
so
CID,
this is the
yeah.
thickness of your cell.
Yeah.
And somehow like some aluminum gets
Yeah,
from
we
here
can
to
figure it
here.
out.
Yeah,
Then that's a bad
Sort of.
Yeah, because you have so you have an additional path.
You can get the
That's
base
bad.
current.
Yeah.
So you
That-
don't want this.
Yeah.
So how like okay, so you just isolate aluminum to the top.
Yeah.
And
What people ideally do is that's why they fabricate an entire cell
Yeah.
and then they
I
cut
think you
this
need
region off.
to find the equation.
I see.
That's what I was thinking.
Yeah, that's all I know.
But if you go to industry, what they do is then
But there's so
iron
many
bombardment.
unknowns that I got no idea. There's UA in the middle of it. I don't know where to find that.
So the my one sides.
Come on, guys. Somebody else give it a shot.
It's fun.
I've run my drum manipulators plenty of times.
Show us how it's done.
I don't have any desire.
Okay, any questions? Maybe? None?
We can go on to the So I'll show